In this video, we will see what type of heat pumps need to be duplicated with a second heat source for heating, also for hot water. We will see how it is used, a heat pump in hybrid mode with the second heat source. We will see how many types of heat pumps exist and why heat pump tip air to air or air to water need to be doubled with another heat source. What does it mean pump operating limit temperature? Which are the world's climate zones? Where it needs to be double the heat pump and where it will be used an electrical resistor inside the heat pump. We will see what are the percentages from the total energy needed for heating and hot water are produced by the heat pump and which are produced by the second heat source. There are many types of heat pumps. The left side represents the extraction medium and the right side represents the transfer medium. So they are air, water, air, sol air or sol water, water air or water. In reality, there are many other types, but these are the most representatives. The basic principle of heat pumps is to reverse the natural flow of heat from warmer to the colder environment by collecting an amount of heat from the colder environment and transferring it to the warmer environment. Here is the internal of a heat pump, and let's see how this natural heat flow from external average temperature goes to the collector. The heat source, the temperature of heat collector is lower as external average temperature. Here what's happening inside the heat pump, and after this one heat obtained on this element with the temperature of heat loss zones higher than the internal average temperature is transferred again through natural heat flow to internal average temperature in the building. Let's concentrate now about external zone and temperature heat collector. Through natural heat flow, we have three types of extraction media: air with temperature between -30 and +40 degrees, water with temperature between +3 to +15 degrees Celsius, and soil with temperature between 0 and +50 degrees Celsius. Now, suppose the temperature of heat collector area of the heat pump is -15 degrees, this zone. The temperature of water as a heat extraction medium is between +3 and +15 degrees Celsius, so minimum temperature difference between it and the heat collector area is +18 degrees Celsius. The temperature of soil as a heat extraction medium is between 0 and +50 degrees Celsius, so the minimum temperature difference between it and the heat collector is +15 degrees Celsius. Now let's concentrate what's happening to the air extraction media. As a heat extraction medium is between -30 and +40 degrees Celsius, so the minimum temperature difference between it and the heat collector area, it can be 0 degrees Celsius. That is, if the temperature of the air drops very low between 0 degrees Celsius, it is possible that the natural absorption of heat from the outside is greatly reduced or stopped altogether. This means that heat pumps with heat extraction medium atmospheric air, the air-to-air or air-water types, have very big problems with the steep descent of the atmospheric air temperature. In addition, with the sharp drop of the atmospheric air temperature below 0 degrees, the phenomenon of ice deposition occurs on the heat collector area, making it even more difficult taking heat from air. For the above considerations, it's clear that there is a temperature below which the heat pump can no longer operate. This is called the heat pump operating limit temperature, and it's specific for each heat pump. It would be normal for this temperature to appear on the leaflets of heat pumps, but in general, manufacturers avoid marking that there is a temperature below which the pump can no longer operate. On the other hand, most pumps have an electric resistance, power high, which compensates for the shutdown of the pump and to switch to the power plant regime. In fact, the high power electrical resistance ensures the possibility of using air or water heat pumps to temperature below minus 25 degrees as it appears in the leaflets. What the manufacturer of heat pumps forget to specify is that under TLO, the pump works as a power plant, which costs per kilowatt of thermal energy 2-3 times higher than in normal heat pump regime. The most heat pump TLO has values between minus 5 and minus 10 degrees, and that is why this problem occurs in the colder climate zones 3, 4, and 5. As seen in the graph on the left, both the pump heating power and the COP drop massively with the outside temperature. In order not to consume electricity for temperature between minus 30 and TLO, it is used for colder climate zones 3, 4, 5, a second heat source, usually a gas or pellet boiler that automatically starts below the temperature of TLO. More about using the second heat source together with heat pump, a hybrid or bivalent working mode, see the video in the description. Also in the video description, you will find for energy auditor or for passionate about energetics of buildings, two links to two different websites about energy performance of buildings and a link to a video with more detailed calculations about heat pumps and using the second heat source. Here is the map of the world's climate zones. I've separated in 5 different zones. Zone 1 with temperature between 12 and 13 degrees Celsius. Zone 2 with temperature between 11 and 12 degrees Celsius. Zone 3 with temperature between 10 and 11 degrees Celsius. Zone 4 with temperature between 8 and 10 degrees Celsius. And Zone 5 with temperature between 6 and 8 degrees Celsius. You will take the average temperature for your city and see in what climatic zone it is. Depending on this, you will read the weight coefficients of the heat pump and the secondary source specific for that climatic zone. What percent of energy needed for heating will be provided by heat source number 2? What percentage of energy required for hot water will be provided by heat source number 2? For warmer climate zones, the energy will be approximately 100% assured by a heat pump, but will be a small percent which when we will use the electric heater inside the heat pump. That means we don't need to invest in a gas container boiler or pellet boiler or a second heat source. For colder climate zones, the situation is different. Let's say we have a situation where the heat pump, air, water, or air ensures 85% for heating and 95% for hot water. That means that the difference, 15% for heating and 5% for hot water, will be assured by the source number 2, an example gas condensing boiler, pellet boiler, etc. Here's how look in general calculation method for what percentage of the energy required for heating will be provided by heat source number 1 and number 2. Here is the calculation method, what percentage of the energy required for hot water will be provided by heat source number 2 and number 1. For heating, we will use the method of number degrees hour, and for hot water, we will use method of number of hours used by source number 2 and number 1. Let's see now how to determine the proportion of energy required for heating to be generated by source number 2 if source number 1 heat pump is switched off at a certain external temperature. the temperature at which the heat source number 2 comes into operation and the heat pump stops. Operating temperature limited of pump TLO for air-to-air or air-to-water pumps is here, and here are the percentage. If the leaflet of the heat pump, the value of the TLO is not specified, consider TLO equal minus 7 degrees Celsius. So we have here for climate zone 1 for heating, climate zone 1 for hot water, climate zone 2 for heating, climate zone 2 for hot water, climate zone 3 for heating, climate zone 3 for hot water, climate zone 4 for heating, climate zone 4 for hot water, climate zone 5 for heating, climate zone 5 for hot water. Again, if the leaflet of the heat pump, the value of the TLO is not specified, we'll consider TLO equal minus 7 degrees Celsius.